Hello, Matthews Gatos here. Welcome back to part 2 of solving radical equations. In this lesson, we're going to look at what happens when I have two roots instead of one. For example, this one right here. So how would I solve that? I have two roots. So in the last video, we looked at what happens when we have only one root. And what we did is we isolated the root. So let's try that. So I'm going to subtract 1 from both sides. 1 take away 1 is 0. So I'm left with 2 minus n, root 2 minus n plus 2 equals to 3 plus n. Once we did that, we just simply squared both sides of the equation to eliminate the root. So if I do that, I get rid of the root on this side, but I don't get rid of the root on that side because really squaring a binomial means multiplying it by itself. And when I apply the distributive property, I get rid of that root, but I introduce a new one there because root 2 minus n times 2 is 2 root 2 minus n. So I'm going to introduce another one. So that process doesn't look like it works. And in fact, when there are two radicals and other terms, so not just two radicals on either side, because we could square both sides and get rid of them. When there's two radicals and something else, like there was the plus 2 there, you can't eliminate both radicals in one step. So when there are two roots, you need to repeat that process 2 times. Isolate one root, square it to get rid of it, and then isolate the other root, square it to get rid of that. So here's the steps. We're going to isolate one of the radicals. It doesn't matter which one you isolate. I always choose to isolate the one that has like a binomial underneath the root sign instead of a monomial. Once you've isolated it, state the restrictions for both radicals and combine them as one restriction if possible. Then square both sides to eliminate the radical that you isolated, and then repeat the process again by isolating the remaining radical. So 2 roots means you do it 2 times. Let's try an example just stating the restrictions. So you can see here in this expression I have 2 different roots. So I want to combine the restrictions if possible. So 2 roots means I have double trouble. I have 2 restrictions that I have to deal with. So in the first one, 2x minus 3 has to be greater than 0. So let's add 3 to both sides to get 2x is greater than or equal to 3. And then let's divide both sides by 2 to get x is greater than or equal to 3/2. In the other root, x minus 5 has to be greater than or equal to 0. So I will add 5 to both sides and get x greater than or equal to 5. So I have 2 restrictions. I want to try and combine them together as one restriction. So whenever your restrictions are both greater than a number, we can combine those by choosing the bigger number. Let me show you how that works, and then we can use this trick every single time. So if I have a number line, 3/2 is less than 5. So let's look at this one time so we can use the shortcut the next time. So x greater than or equal to 3/2 means starting here and increasing. In my other one, x greater than or equal to 5, here's 5, and it's greater than or equal to that. You can see the overlap happens when x is greater than or equal to 5. So this is my one and only restriction. X greater than or equal to 5 covers both. So when I have restrictions where they're both greater than, combine them into one by choosing the bigger number. So let's try this one here. We're going to do the restrictions and then we're going to solve. So I'm going to isolate my root. So I'm going to isolate this because it's a binomial root. I want to get rid of that one right away. So I'm going to subtract 5 from both sides. And don't worry if you chose the other one, that's okay. We're going to get there in the same, maybe not the same way, but we'll have the same answer. 7 take away 5 is 2 plus root 3x. So stating my restrictions first, I have 2 roots, so I have double trouble. I have 2 different restrictions. So in my first restriction, 5x plus 4 has to be greater than or equal to 0. So subtract 4 from both sides, and I get 5x has to be greater than or equal to -4. Divide both sides by 5, and I get x is greater than or equal to -4/5. In my second one, I have 3x greater than or equal to 0. So divide both sides by 3, and I get x is greater than or equal to 0. So remember, when they're both greater than, choose the bigger number, and that will be the restriction for both. So the restriction that covers both is x greater than or equal to 0. So now I'm ready to solve. So because I have two roots, remember, two roots means I do the process 2 times. So let's try the first. So I'm going to square both sides to get rid of my root. Now squaring a root, squaring and square rooting are inverse operations, and that cancels. But on the other side I have a binomial, and remember, with a binomial I want to write that out 2 times, just so I don't make any mistakes. So here I have 5x plus 4 equals, now I apply the distributive property. So 2 times 2 is 4. 2 times root 3x, root 3x times 2, root 3x times root 3x. Remember that root of the same thing times root of the same thing equals the same thing without the root. So you can still see I have a root there. That's why I have to go through the process 2 times. So let's combine my like terms. So I have 4 plus 2 root 3x's and 2 root 3x's is 4 root 3x's. And I want to isolate my root. So I want to get this guy here all by himself. So I'm going to subtract 4 from both sides and subtract 3x from both sides. So 4 take away 4 is 0, 3x take away 3x is 0. I'm left with just 4 root 3x on that side. On the other side, I have 5x take away 3x is 2x, and 4 take away 4 is 0. Let me write that a little closer. So this is my new equation that I'm going to solve. So over here, I have my equation, still have that restriction where x is greater than or equal to 0. Now I have a little tip for you. If I were to divide both sides by 2, I'd make my numbers simpler. I could divide both sides by 4, but then I would introduce a fraction. So what I'm going to do is 2x equals 4 over root 3x. I'm just going to divide both sides by 2, just to make my numbers a little simpler. So 2 divided by 2 is x, 4 divided by 2 is 2. Now, if you wanted to divide both sides by 4, you could also do that, and you'll end up with the same answer. We just have a fraction. So what I'll do is I'll show you that in case that is your preference. So if I had 2x equals 4 root 3x, and you want to divide both sides by 4, then I would get 2x divided by 4. Well, 2 over 4 in lowest terms is a half. So 2 different ways of solving it. You choose the way that makes the most sense for you. So let's solve this first one here. So I have a root which I want to get rid of, so I'm going to square both sides. So x squared equals, now when I have anything other than a root, I always recommend writing it out 2 times just so you don't make a mistake. So this is x squared equals 2 times 2 is 4, and then root of the same thing times root of the same thing is the same thing without the root. So I really end up with x squared equals 12x. Now let's do the same thing on the other side, see if we end up with the same answer, and then you can decide which way you prefer better. So on this one here I have my root isolated, so I'll square both sides. So squaring a square root are inverse operations, so I'm just left with my 3x. Over here I have x over 2 squared. Again, if it's not just a number, I always write it out 2 times. So I have x times x is x squared over 2 times 2 is 4. Now I don't want a fraction, so I'm going to now multiply both sides of my equation by 4. So you see 4 divided by 4 is canceled, and I'm left with x squared equals 4 times 3x is 12x. So you see we get the same answer, so it's really a matter of personal choice which one you like better. So let's continue on with this question here. I'm just going to make it a little bit bigger for us to see. And let's talk about how I solve either one. Either equation, they're the same. So if I want to solve x squared equals 12x, I have a little tip for you because I find that there is a temptation here to divide both sides by the variable. So I want to be super clear. You can never divide both sides of an equation by a variable because you throw away one of your solutions. So anytime you have a quadratic, and geez, that doesn't look like a quadratic, does it? Let's try that again. Anytime you have a quadratic, the rule is set it equal to 0, factor, and solve. So that's what I'm going to do. So resist the temptation to divide both sides by a variable because in math, that's a big no-no. So let's take that tip aside, and I am going to subtract 12x from both sides. And now I'm going to factor. So I have a greatest common factor of x that I factor out, and I have two potential solutions. X equals 0 or x minus 12 equals 0, which means x equals 12. So I want to check that question now. I want to check it against my restrictions and also in my calculator. So let's look. The solution has to be greater than or equal to 0. Well, both of those are greater than or equal to 0. So maybe I have a potential for both to be my solution. So let's just move these guys over so I can make room for my check. There we go. Okay, and let's look at my check. Oh, there we go. Oh my goodness, I'm making it worse, aren't I? There we go. Okay. So let's look at my check now. So in my check, what I'm going to do is I'm going to put my original unchanged question in Y1. Left side and right side. Left side in Y1, right side in Y2. Now I think 0 and 12 are my solutions, so I start my table at 0 and then I start my table at 12, and you can see for both of those solutions, y1 equals y2. I didn't show you the rest of the table because we're really only looking for x equal to 0 and x equal to 12. So I know those are both my solutions. Let's go ahead and try another question. So in this one here, again, we want to start with our restrictions. So I have two roots, which is double trouble, two different restrictions. So in my first one, 3 plus j has to be greater than or equal to 0. So I'm going to subtract 3 from both sides and get that j is greater than or equal to 0 take away 3 is negative 3. In the other restriction, 3j minus 2 has to be greater than or equal to 0. So let's add 2 to both sides and divide both sides by 3. So I have two different restrictions. They're both pointing in the same direction, greater than. So remember my shortcut, I choose the bigger of the two. So my restriction is going to be j is greater than or equal to 2/3. Okay, let's go ahead and solve. So remember, when I have two roots, I do the process 2 times. Now, one of my radicals is already isolated, so let's go ahead and solve by squaring both sides. So squaring a square root are inverse operations, so I'm just left with 3j minus 2 equals, and then I'm going to write this out 2 times. Again, anytime I don't have, or I have anything other than just a root, I would always write that out 2 times just to play it safe. So I have 3j minus 2 equals distributive property, 7 times 7, 7 times the negative root, the negative root times 7, and negative root times negative root is positive, and then remember, root of the same thing times root of the same thing is just the same thing without the root. Okay, let's tidy up by grouping like terms. So on the right-hand side, I have 49 plus 3, so that's 52, plus j, and then I'm going to combine my like terms here. So negative 7 and negative 7 altogether is negative 14 root 3 plus j's. Okay, so I want to go through and get my root isolated. So what I'm going to do is subtract 52 from both sides. There we are. And subtract j from both sides. So I have 3j, take away a j is 2j. Negative 2 and negative 52 is 54, equal to negative 14 root 3 plus j. So at this point here, we have to make a decision on how we are going to simplify. And I think similar to the last question that we did, instead of introducing a fraction, what I'm going to do is divide by a common factor of 2, more specifically negative 2. So I'm going to divide this side by negative 2, this by negative 2, and this by negative 2. So I'm going to divide all my terms by negative 2 to be fair. So 2j divided by negative 2 is negative j. Negative 54 divided by negative 2 is positive 27, and that will equal to negative 14 divided by negative 2 is 7 root 3 plus j. So that's what I am going to use in my next step to isolate my variable, my radicals isolated, to square both sides and solve for j. So over here, I'm just going to adjust this because I did this with a negative. So I'm going to do it as negative j plus 27 equals to 7 root 3 plus j. Okay, so I'm going to square both sides. And either form is fine. It's really a matter of personal preference. So here I'm going to write this out 2 times. So negative j plus 27 times negative j plus 27 equals to, again, I'm writing that out 2 times because I don't just have a simple root. So I want to avoid the chance of making a mistake. Okay, let's move all of this over. There we go. So let's apply the distributive property. So negative j times negative j is j squared. Negative j times 27, negative 27j. 27 times negative j, negative 27j, and 27 multiplied by 27. I'm just going to check that one on the calculator. 729 equals to, on the other side, 7 times 7 is 49, and then root of the same thing times root of the same thing is the same thing without the root. So let's tidy up here. On the left-hand side, I'm going to combine my like terms. On this side here, I'm going to apply the distributive property. So 49 times 3, 147, and 49 times j. So I have a quadratic, and with a quadratic, I want to set it equal to 0 and then factor or use the quadratic formula. So I'm going to subtract 147 from both sides and subtract 49j from both sides. So you'll notice on the right-hand side, everything cancels out. So 147 take away 147, 49j take away 49j equals 0. Oh, I forgot to write my subtract 49j here. Okay, so I have j squared, negative 54j, take away 49j is negative 103j. And then I do 729, take away 147, and I get 582. Now at this point here, you can solve using the quadratic formula, or you can solve using factoring. It's really a matter of personal preference. I'm going to solve it by factoring, but I need a helping hand on my factors. So there we go. There's the factors. Oh, how did I get that answer? Did I make a mistake on that? Let's just see. Let me go back up and check my math here. So 27 times 27 is 729. That is good. 49 times 3 is 147. Take away 729. Yeah, that should be 582. So maybe I just wrote this down wrong when I brought it over. Let's just double check that 97 times 6. Yes, this is a mistake. Okay, here I thought I did the question wrong. Okay, so that should be 582. So that's just a typo. Okay, so I have my two factors, so I'm going to set each factor equal to 0. So here adding 97 to both sides, here adding 6 to both sides. So the first place I check is my restriction, which is j greater than or equal to 2/3. That works out to be true. So the second place I'm going to check is my calculator. So I have two solutions to check. Let's just go down here so we can see my solutions, and I'll make this a little bit bigger for you. Okay, so if I go down here and I go onto my calculator, you can see I went back to my original equation. I put the left side in y1, the right side in y2. I start my table at 6, and I can see y1 equals y2. And then I start my table at 97, and I can see that they are not equal. So that tells me that only 6 is a solution. So this is wrong. That's not a solution. So the only solution is j equal to 6. Okay, I just want to end with doing a word problem. So in this word problem here, I have a drumstick that fits exactly along the diagonal of a cube-shaped moving box. If the drumstick has a length of 23.3 centimeters, what are the dimensions of the moving box? Now it is a cube, so I know that all my sides are equal. And we're going to express our answer to the nearest tenth of a centimeter. Okay, let's examine this a little bit closer. So if I look at my package, I have my drumstick that measures 23.3, and this is in a three-dimensional plane. So I have my side length, which is going up. That's the side length of the cube. They're all the same. And then I have the diagonal of my square base. Well, that makes a right triangle. So in a three-dimensional plane, all those measurements are meeting together at a 90-degree angle. The side length and the diagonal of the base are a 90-degree angle to one another. Now, this isn't going to help me because I don't know what my diagonal of the base is. I don't know the side length. All I know is the drumstick is 23.3. So I need to look at something a little bit different. So since I want to come up with something for my drumstick, I know my side length is x, but what's my drumstick? I'm actually going to look at the base of the cube. The base of the cube is made up of a side length x, and a side length x here, and we want to solve for the diagonal. So let's use Pythagorean theorem to come up with an expression for the diagonal of the base. So x squared plus x squared is equal to c squared, which would be the diagonal. So I'm going to have 2x squareds equal to c squared. So take the square root. Now I know when I take the square root, it will be positive and negative, but I'm talking about the length of the diagonal, so it will only be the positive root. So it'll be the root of 2x squared. So let's simplify this down into perfect and non-perfect factors. So x squared is a perfect factor, but 2 is not. So I'm left with the square root of 2 times the square root of x squared, which is x. And that is the diagonal expression. So now I have side length in x, I have a diagonal in terms of x, and I have the drumstick, which is a number. So now I can solve what the side length is. So I'm going to take this triangle with my new measurement for a diagonal and solve for the drumstick. Okay, so again, these are all at 90-degree angles to one another. So using Pythagorean theorem, I've got x squared plus root 2x squared equals to 23.3 squared. So let's simplify this. I have x squared plus, I'm going to write this out 2 times just because I don't want to make a mistake. And then 23.3 squared is equal to 542.89. Okay, so let's keep going. So x squared plus root 2 times root 2 is just 2 and that's x squared, equals 542.89. So altogether, this is 3x squared equals to 542.89. So to solve for x, what I'm going to do is divide both sides by 3. And x is going to equal to 180.96, and then the 3 is repeating. So that is what x squared is equal to. So in my final step of this question, I am going to square root both sides. Again, I only need the positive square root because it is a side length. So taking the square root of this answer, x is equal to the nearest tenth, 13.5 centimeters. So what that tells me is that a drumstick measuring 23.3 centimeters can fit into a cube box measuring 13.5 centimeters on each side. That was a challenging question for sure. Hopefully you guys understood that and followed that. So that's the end of solving equations with two different roots. And I hope you guys really see that math teachers always get to the root of the problem. So you guys can go ahead and do practice questions that are in my notes and then move on to your textbook questions. I hope this video helped, and I look forward to seeing you for the next one.